We're going to work on solving logarithmic equations next. So here's a process and then we'll apply it. So first we're going to use logarithms to rewrite the equation so it has only one log. So we're going to probably have to condense some logs together. Then we're going to isolate that log on one side, make sure that it's all by itself. And then, and this is the trick, we're going to convert the equation to exponential form. We know how to convert between log form and exponential form. And so we will do that, and that will get rid of the log. We will then solve that equation for our variable. But this is another one where you have to check, because you need to make sure that any solutions you find are in the domain of the original equation. Remember, you cannot take the log of 0 or a negative number. So you have to take your answer, you have to look back at the original equation and make sure you're taking the log of only positive numbers. All right, so let's go through a few of these. Let's start with number 1. I've got a log base 2 plus another log base 2. So my goal is to rewrite this as one logarithm. Since I'm adding, my properties of logs tell me that I will multiply those two things. So it'll be log base 2 of 2 times 3x minus 5. So I can multiply that out. Now I have one log. It's by itself on one side. So here's the step where we convert. We want to rewrite this logarithmic equation as an exponential equation. So remember that base stays the same. The exponent is on the other side of the equals. So 2 to the third equals 6x minus 10. That's the step that most people get a little confused by, or they forget to do it. And it's just converting from log to exponential form. So then I'm just going to solve what I have here, which will isolate the x on one side. Now, the last thing I do before I put a box around that is I double check if I plug 3 in, well, that's just a log of 2. Here I'd have 9 minus 5, which is 4. So I would be taking the log of a positive number. So I'm okay to keep that solution. Okay, let's try another one. All right, I'm going to isolate the log first. Divide by 2. So ln x equals 2. Now remember, ln is base e. So when I go to convert this, it'll be e squared equals x. And if I were to plug e squared as a positive number, and if I were to plug that into my original, I would definitely have the log of a positive. All right, continuing on, I have another ln, but this time there are 2 being subtracted. So I'm going to use my properties of logs to condense that into one logarithm. Rewriting an exponential form would give me e to the 4th equals now I'm going to multiply both sides by that x plus 3 to get it to cancel. You could also think of it as cross multiplying if you want to, either way. So I'll have x plus 3 times e to the 4th equals just x, and that's just from multiplying both sides like this. Yeah, I've got 2 x's and one's kind of stuck inside the parentheses, so I am going to have to distribute that e to the 4th so that I can work on getting all my x's on one side and factor it out. So I have 3e to the 4th over 1 minus e to the 4th is my x. Now, in order to make sure, see, I have an ln of x. and an ln of x plus 3. So as long as what I had, this answer is a positive number, then it plus 3 will also be positive. So that's, do you know what this is exactly equal to? Probably not. So I'm going to go ahead and just plug it in my calculator. 3e to the fourth. Well, if I could get it to plug into my calculator correctly. And then I'm going to divide that by 1 minus e to the fourth. And that is a negative number. E to the fourth is definitely bigger than 1. I got a negative, 3.1 if I round to the nearest tenth, which will not work, will not be in the domain of this equation. So that means I need to toss that. This is actually not an answer. And so this particular equation has no solution, since that was the only answer that I had, and it is not in the domain of the original function. I think I had one more. Oh, there it is. Okay. So you got one more here. Let's go ahead and give it a try. Now, there are kind of two ways to do this. In this case, I have log, log, and log. So I could rewrite as one logarithm and then convert, but since everything is a log, I could do something similar to what we did with the exponential. So I'm going to use my properties of logs to rewrite the left side. So because of the minus, I divide it. And now I have common log of this equals common log of that. Similar to exponentials, like 3 to a power equals 3 to a power means the two powers are equal. If I have the same base log and they're equal to each other, you can basically just drop the logs. And whatever is inside has to be equal to each other. So that's kind of a shortcut, an easier way to do something where everything is a log of the same base. If you zoom out here, that doesn't apply in this situation because I don't have an ln 4 over here. I just have a 4. And it didn't apply up here either because I don't have an ln equals an ln or a log base 2 equals a log base 2. So that this sort of shortcut only applies in situations where you have the same log on each side equal to each other. All right, I'll multiply both sides by 2. I've got 3x minus 2 equals 2x plus 8. So I'll move the x's to one side and the numbers to the other. And just double check that that 10 gives me a positive number inside the log here, which it does. That one is a constant, and it's another positive number. So we can keep that solution. I think I actually already answered this up here. I just did the problem that way. Both sides have logarithms of the same base, so we used a shortcut there. I wanted to make sure I noted that.